these are the three types of problems that you've been having. 1 and 2 come from the worksheet that you did on, you got it on Friday and then you turned it in on Tuesday. You remember that? Had a bunch of fractions on it. A lot of you just don't know what a trig ratio is. What does the word ratio mean? A fraction. That means a relationship between numbers, which is going to be a fraction. So it says, like 1 says tangent of z. So from angle z, I need to find the ratio that is tangent from SOHCAHTOA. SOHCAHTOA. What is tangent? Opposite over adjacent. So what is the opposite side? 21. What's the adjacent? 28. So you would write a fraction 21 over 28. Do we reduce in math?
Yes.
We do. They're both divisible by 7, so it's going to be 3 over 4. All right, so that would be your final answer. If you look at the two types of problems you had on the classwork from yesterday, one of them says find the measure of the indicated angle. One of them says find the missing side. You do the same thing for both. Okay? Whenever you're missing an angle, you're going to use a very special button. So I want you to write it down again. So take your pencil or your pen. When you have a missing angle, so write this down. When you have a missing angle, that is when you use the inverse. Which means you're going to hit shift and sine, cosine, or tangent. That will never ever change. You will never use it if you're missing a side. You will only use it if you are missing an angle. Alright, so like in number 7, from the angle that we're finding, what kind of side is 51? Opposite. What kind of side is 55? Hypotenuse. So what trig function is that? Sine. From what angle? You can call it whatever you want.
J.
It doesn't have a... You can call it J if you want. Jalen. You can call it X, you can call it whatever in the world you want. You can call it theta. Theta is a letter too. So it will be opposite of our hypotenuse, which is 51 over 55. Then how do you solve for X? Yeah, sine to the negative 1. So shift sine, and then type in 51 over 55. Hit enter. Go. We're rounding to the nearest degree, so the whole number. 68 degrees. So when you're missing an angle, you will use the inverse button. If you are not missing an angle, you will not touch the inverse button. Okay? Number 1 is from the second portion. Find the missing side. So you want to use the angle that was given to you, 27 degrees. Are you missing an angle?
No.
No, you're given it 27 degrees. What kind of side is X? Opposite. What kind of side is 10? So SOHCA or TOA? Tangent, because it's TOA. So tangent from what angle? 27 equals the opposite, which is X, over the adjacent, which is 10. What's happening to X? It's being divided by 10. So what's the opposite dividing by 10? Multiplying by 10. So multiply both sides by 10. So you type in 10 tangent of 27 and round to the nearest, it says 10. Type it in. 5.1. So know the difference between these, because this type of problem, like 1 and 2, these should be like the easiest problems on your quiz or test, because all you're doing is writing a fraction. You're not doing any other math. You're literally just knowing SOHCA, TOA. Those 3 things. Today, we're going to talk about word problems, because on your quiz, there are 9 problems, I think, and 4 of them are word problems. And they're all about trigonometry. So, right triangle trigonometry. At the top of that page that I gave you, it says the Pythagorean theorem word problems. I want you to cross that out, because I used to split this up into 2 lessons when there's really no need to.
Cross out the whole thing.
So Pythagorean theorem, you can cross out. This is going to deal with a right triangle. Okay? So write triangle word problems. You may use the Pythagorean theorem. Sometimes you won't. So we're going to talk about write triangle word problems. They use the same type of lingo. So if you learn the lingo, you know how to do these problems. Okay? So, starting with the very first blank on the vertical side. So that's the left side of your paper. You're going to write height. Because this side will always be the height of something. So this side right here, there are a bunch of blanks. You're going to write height. So if it talks about the height of a building, the height of a person, the height of a dog, I don't know, the height, that's what's going to go on the first blank. All right, so the next thing is a pole. Like a flagpole. He's laughing at something else. A flagpole. You got a telephone pole.
What is so fun?
He's laughing at something different than you're laughing at. So, that's the second blank that you have. Alright, next blank will be a wall. You are behind. Come on. So you should have height, pole, wall. When it talks about a wall is 15 feet high, okay, that is the height of something. That's also a wall. So whenever you see the word wall, that's going to be the vertical side. Whenever you see tree. Now, please don't get technical with me because some of you are going to try and you're going to think you're funny. No, I won't. Because not all trees are completely vertical. I know that. You know that. We live in Florida where hurricanes are around. So some trees lean. In trigonometry, trees are just going to be completely up and down. Okay? Completely vertical. All right? The next would be the top of a blank. So fill in that blank. It could be the top of the slide, the top of a building, the top of a skyscraper, the top of a mountain. Doesn't matter when it says the top of a blank. You're going to be talking about the vertical. And the last blank would be the length, the length of a box. It would also be the length of a court or a field. So court or field. I think one of the problems you're going to do tomorrow says a soccer field is so-and-so meters by so-and-so meters. Find this. Okay? So if it says that, when it's a length, it's going to be the vertical. Now we're going to move to the horizontal. This is like the most forgotten about side. I don't know why. But it's the one that's almost always there. What do you think usually represents the horizontal line?
Grass.
Okay, the ground. Not necessarily grass, but the ground. Even though grounds are not always perfectly level. Yes, ma'am. Even though grounds are not completely level all the time, in trigonometry we all agree that they are. It's just understood. Yes, dear. Alright, the next one is the distance. Please write down every single word because you are literally going to have this and half of you are not going to know because you didn't write this down. Distance from a building, a pole, a base. Because when you measure distance from an object, you will not measure the angle distance like the hypotenuse. That's not a thing. You won't measure up and down. You will measure the horizontal distance from you to that object. So this kid, whoever he is, the distance from him to that building is from the base of that building to his foot. So it's going to be the distance. All right, you're going to see the word base a lot. When you think of the word base, what do you think of? The foundation, the bottom of something. So keep that in mind. Yes, ma'am. All right, the next portion. A shadow on the ground. From the start of the shadow to the end of the shadow. And also the width of a box or of a court or of a field. All right, so that will be that horizontal line every time. If it's not one of those options, it's probably not that line. All right, the next one you don't have to write because hopefully you know what a hypotenuse is and where it is. A lot of people use the hypotenuse for things that it's not. There are very few times that you'll use it, so make sure you use it wisely. Use the hypotenuse, this is your first bullet point, when something is leaning or unstable. So leaning or unstable, it will never be the distance to something, it will never be the height of something, it will always be something leaning or unstable. And what I mean by that, if you have a kite and you have the string, whatever, it's not a pretty looking string, let me try. Okay, you got the string and here you are holding it in your hand. Weird looking guy. This is an unstable object. It's not a set thing. Like string is, I mean, it can move, it's flexible. Does that make sense? So, like distance of something, that is not unstable. That is a clear-cut thing. The height of something, that is a clear-cut thing. But the things that are for the hypotenuse, they're always leaning or unstable. So, what is this guy walking on? A ramp. So that's your first blank. Oh, or second blank. A ramp. Yes, it's from Brain Pop. I didn't know that when I made this. I've heard it 4 times now. Yep, heard it 4 times. Alright, so here's a ramp. So that should be your second blank. Next one. What do you think? A ladder. A ramp. So listen, a lot of you, at least all today, they were like, no, some ladders go straight up. I'm just telling you, it is understood in the math world, normally, especially for high school students, the ladders that we talk about are leaning. I know that there are ladders that go straight up, like when they're attached to a building. Someone earlier was like, what about the ladders that are on a playground? Okay, I'm sorry that you go to a playground when you're in 10th grade, but I'm just saying, the ladders that you'll see in these word problems, they're going to be leaning, because most people walk on a ladder like this. All right, next one will be a rope or a wire hanging from a pole. You could also put a string from a kite. So you'll see sometimes it'll talk about like those telephone poles. I don't know if they're telephone poles anymore, but that's what I call them. They're not orange, but do you know how there's one that gets stuck into the ground? Mm-hmm. Okay. It would normally be talking about that part of the line. Okay, so that would be the hypotenuse because it's leaning. All right. Then you can write down the string of a kite. I know it's not up here. I drew it, but the string of a kite. And then the last, if you see the word diagonal, that's going to talk about the hypotenuse. So the diagonal of a box or a field. And the very last portion is in the bottom left of the whole paper. It is a compass. Now, whenever it says north and south, that is going to be the vertical side. When it says east or west, that is going to be the horizontal side. Now, please don't argue with me. If you look at the compass on your paper and on my board, west is on the left and east is on the right. But if you say it out loud, normally you say east and west. You don't say west and east because it just sounds weirder, okay? So I wrote east and west. If it really bothers you on your paper, you can do differently. Here's west and here's east. But most people say east and west. FYI. Nobody says west and east. You know what I mean? That just sounds weird. You do. And where are you from? Just kidding. I'm just kidding. All right. So let's do some together. You are not going to throw away this paper. You are not going to put it away. You're going to put it beside you. Because guess what? When you draw a picture, the words that you're going to find on the screen are going to be on this page. So you need to figure out which side is which, because obviously this whole section is about right triangle. So what should every picture end up looking like?
Right.
A right triangle. And if it doesn't,
You're wrong.
you did something wrong. Okay? So, Daniel rides his bicycle 21 kilometers west and then 18 kilometers north. How far is he from his starting point? So, he starts, let's say he starts at his house. I don't care where he starts, but this is his starting point. Starts. Beautiful house. What does he do? The first thing.
You ride
21 kilometers west. Which direction is that?
Definitely.
To the left, to the left. So, 21 kilometers, pause. Because I'm telling you, you guys, maybe not you, but a lot of students don't know the difference between an angle and a side. 21 kilometers is a length, correct? It's not a degree. So this is going to be a side length. When you go to draw these, I promise you, so many kids today put that inside of the triangle and said it was an angle. This doesn't make any sense. If it says kilometers, inches, feet, yards, meters, millimeters, those are all lengths, not degrees. If it says degrees or a little bubble, that's an angle. All right? Quan's laughing because he learned that in first grade. So he goes, Daniel goes 21 miles west, so he goes left. Then what does he do? 18 kilometers north, so he goes up. It is understood that when north and south and east and west meet, they make a 90-degree angle. They are perpendicular to each other. So, how far is he from his starting point? When you measure the distance of something, you don't measure like the longest way. You measure the shortest way. Okay? So it's asking for the hypotenuse. You're given two sides in a right triangle. How do you find the third? The Pythagorean theorem. You don't use SOHCAHTOA because you're not finding an angle. You need to find a side. So you're going to use Pythagorean theorem. So, are we missing a leg or a hypotenuse? Hypotenuse. So you're going to do 18 squared plus 21 squared equals x squared. Alright, so you should get 765 equals x squared. Take the square root. If I were to ask you how far you live from the school, would you say the square root of 13 miles?
No.
No, you would not. You would tell me how far you live, okay? And whether it's whatever. You would use a decimal, alright? So if you round to the nearest tenth, you should have 27 point, what is it? 7, and then we're in kilometers, so kilometers. You are measuring the height of a lamp post. So first thing you want to draw. I mean, I don't know how to draw a lamp post, so I just do that. It is what it is. Just draw a stick. I'm pretty sure it's self-explanatory. It's a post with a lamp on it. I don't have the ability to draw that, so just draw. What are you drawing? You're not drawing anything. Come on. Draw on this picture. Alright, so if you read the problem with me, it's a lamppost. Where have you been? You stand, so listen, you stand 40 inches from the base of that lamppost. So if you're standing a distance from the base, look at that paper directly right now. Yeah, you don't have to say it out loud. You look at the paper yourself, and you decide which side it's going to be. Are you reading all the options?
Yes. No.
It's the distance from the base, so it's going to be the bottom. And it says we're 40 inches away from it. So that is a length, correct?
Yes.
So it depends distance from an object.
Yes.
You measure the angle of elevation from the ground, so here's the ground right here in this corner, to the top of the lamppost. So ground to the top of the lamppost. To be 70 degrees. Is degrees a side?
No.
It's an angle. So it needs to go in a corner inside of this triangle. I'm tired of people saying 70 degrees out here. 70. It goes inside of the triangle. Angles are made up by two things that come together. All right, so this side and this side. Angle of elevation would be down here. Elevation opens upward. And you'll also learn that it has something to do with a horizontal line. Which of these is my right angle?
The one in
The bottom left.
yeah.
The reason is, if you're measuring the height of something, that should be up and down, because you measure straight up and down. And then the ground is supposedly always perfectly level, so it should make 90 degrees together. Alright, so then it says find the height, h, of the lamppost. So look at your paper, do not say it out loud. Look at your paper and figure out which side represents the height of something. And draw it on your paper. It's like the first word on that side. Alright, so we're finding the height. Now we're going to use trigonometry. Because we can't use the Pythagorean theorem, you need two sides. Do you have two sides? You only have one side and one angle. If you had a side and an angle, you need to use right triangle trigonometry. So from this angle, you're going to use SOHCAHTOA. What kind of side is H? Opposite.
Opposite.
Don't let the H fool you. That's right, Hannah. 40 inches is what kind of side? Adjacent. SOHCA or TOA? TOA. So tangent from what angle? 70. Equals the opposite, which is H, over the adjacent. 40. So what's happening to H?
It's being divided by 4.
Being divided by 40. So what's the opposite? Multiplying by 40. Alright, so put it on your paper. Don't say it out loud. Any questions on how we did this problem? Okay. So, here's what you're going to draw. You have to follow with me. You're going to take the triangle paper and flip it backwards. Upside down. So take this paper, you're going to draw them back. There should be nothing there. Here's what you're going to draw first. Draw a stick person. That's all I'm asking of you. Stick person. I don't care if you can draw better than that. I don't have time for you to draw better than that. Stick person. From there, I want you to draw a horizontal line from the eyesight. I'm not super picky. Just a horizontal line. Here's what I want to emphasize to you. Angles of elevation and angles of depression are always made with a horizontal line. The problem that we just did, this was my H, this was, 40 inches? And it said there was an angle of elevation of 70 degrees. The only reason this was possible is because the ground is supposedly perfectly flat and horizontal. And then the angle opened upward. So, whenever you have angle of elevation or angle of depression, you have to have a straight line. It's easier on elevation because normally it's with the ground. Angle of depression is harder because you have to draw an imaginary horizontal line. Alright, so after that you can, I just want to emphasize, you need a horizontal line. So please write that. You need. So you need a horizontal line like you need food and water. Okay? You can't have an angle of elevation or depression without it. Once you've drawn that, then you can draw the other portions as well as the words angle of elevation and angle of depression. Alright, this is from your textbook. The top of the slide is 12 feet from the ground and has an angle of depression of 53 degrees. What is the side length of the slide? So here's what we're going to do. We have a slide, correct? Do slides float? Do slides float in space?
No.
They don't. They have to have a ground. So you can draw a ground. Draw the ground. There you go. There's a straight line. Since the top of the slide is 12 feet from the ground. So, look at your paper. It's 12 feet from the ground. Is that going to be the vertical line, the horizontal line, or the hypotenuse? A vertical line, because it's the height of something. Oh, man. Here. Alright, so that is what, 12? 12 feet. Alright, so think that as like the stairs, we're making this 2-dimensional and not 3-dimensional because I'm not that talented. Alright, after that, it says there's an angle of depression of 53 degrees. So what did I tell you have to have an angle of depression? A horizontal line. So you're going to, from the top, because all of this is in reference to the top of the slide. So you're going to draw a horizontal line from the top of the slide. This is my horizontal line. Doesn't have to be perfect, but you need a horizontal line. Alright, so the angle of depression from the top of the slide. So you're going to draw from the top of the slide and down. Top of the slide and down. So where all three of these meet, this is called the top of the slide. Oop. Slide. Alright, so how many degrees is this angle of depression?
53.
53. So from the horizontal line, which is in blue, and the red line, which is the slide, it's going to be 53 degrees. Most people would put 53 degrees here, which would be incorrect because there is no horizontal line. Okay, you have to draw a horizontal line. Alright, from here, what is the length of the slide? So, it doesn't look like we have a right triangle yet, but we do. You just don't know it. So you could do one of two things. One of two things. And I think one is easier because most of you cannot remember the word perpendicular for the life of you. If this gray line is 12 feet tall, that's from the horizontal line to the ground. How high is it on the dotted line I just drew? It's also 12 feet because both of them are perfectly horizontal. So, where a vertical line meets, that's the purple, and the blue line meets, which is a horizontal line, where vertical meets horizontal, what does that create? A right angle. There's a right angle. So we're dealing with this triangle right here. What is the length of the slide? So is that going to be the blue or the red? The red. Because again, here's the stairs of the slide. I just made it 2-dimensional. This was the top of the slide, so that makes this the slide. So you can call it whatever you want. You can call it X, you can call it S. I don't really care. I'm going to call it X just because. So now is when you use SOHCAHTOA. From 53 degrees, what kind of side is 12? Opposite. And then what kind of side is X? Hypotenuse.
Oh, yes.
So what trig function are we going to use? Sine. From what angle?
53.
Equals the opposite, which is 12, over the hypotenuse, which is X. Can I multiply 12 on both sides?
No.
No, that would not help me. So what do I need to do? I need to flip both sides. So sine is invisibly over 1. So it's going to become 1 over sine of 53. And I'm going to flip the other side as well. X over 12. So now X is being divided by 12. Now I can multiply by 12. Make sure when you type this into your calculator, you end the parentheses. Round to the nearest 10th. Some of you haven't even touched your calculator, and if I called you out, I'd really embarrass you. So I suggest that you type it in your calculator. Did you round correctly?
Oh, wait, no.
Should get 15 feet. If you did not get that, raise your hand so I can look at your calculator. right, so you have a ladder. Oops. You have a ladder leaning against a wall. Man, that's ugly. Start over. I'll draw the wall first. You got a wall. Got a ladder. It's even uglier. It is what it is. And then you're going to close the sides because you need a right triangle because that's all we've been dealing with. A right angle will always be made with the wall and the ground. So wall and the ground, here's your right angle. It says the angle of elevation of a ladder is leaning against the wall is 70 degrees. Yes. So it says the angle of elevation. Angle of elevation has to be against a horizontal line. This angle up here is not against a horizontal line. Horizontal goes left and right. So this angle down here is the angle of elevation, and it is 70 degrees. The base of the ladder is 1.4 meters from the base of the wall. So which of the sides do we use to measure the distance from something?
The bottom.
The bottom. So the bottom should be 1.4 meters. Then it says, find the length of the ladder to the nearest tenth. So the ladder is what's leaning against the wall. So it's the purple in my picture. So from 70 degrees, what kind of side is 1.4? Adjacent. What kind of side is x? Hypotenuse. So you're going to use cosine. Cosine from 70 degrees. It'll catch up with me. Equals 1.4 over x. Don't put anything away. Can I solve this the way it is? What do I need to do? Flip. Again. Don't test me. I need to see on your paper. Show me on your paper what you get as the answer. Okay. I would check that. What? It's not correct. You get 4.1. A lot of you are not getting that answer.
How would you type it in a calculator?